Hello everyone. Thank you first of all for having me here, and thank you, Sid, for your help in organizing this. I'm Ashwath. I'm an intern at IBM Research. I'm a part of the Responsible Tech team, where I'm working on this project called the Responsible Prompting API. So, to give a very simple overview, it is a system that recommends addition of good values and removal of harmful values from the prompt during prompting time. And of course, I'll explain more about how exactly it works in the presentation. And throughout this presentation, if you have any doubts or questions in the middle, feel free to stop me. I'll also pause in the middle for a bit to see if there are any questions. Yeah. So for this project, it is important to discuss the context in which it works and how different it is from the other existing systems. You might already know of alignment fine-tuning, which happens at the end of the training process of an LLM. And you might also be aware of guardrails, which basically catch harmful outputs post-inference after they are generated. This responsible prompting system works entirely pre-inference, that is, before any prompt is sent to the LLM or any other GenAI model for that matter. It is important to make this clear because this system is not proposed as a replacement for alignment training or guardrails. They are still necessary and they are useful. Our system is designed more of a guide to the user in prompting effectively. And on top of that, in terms of catching harmful outputs, uh, it doesn't see the actual output, so it's not going to be 100% accurate. But even if it catches, let's say, 40% of what would be harmful outputs, you're still saving on that wasted computation of an output being generated and eventually caught by guardrails and thrown out anyways, right? So we will be saving up on the time and cost of running that inference if we are able to catch it in prompting time itself. And I want to make it clear why it is important to think about this in this age, because right now the world is starting to adopt more and more of these GenAI systems, but there is still a lack of guidance around how to prompt the system effectively. Most users do not want to misuse it, do not want to be unethical in their interactions with an LLM, but it is still much of a mystery, and we could use some guidance in that sense. And in this is an opportunity to embed social values into the content that is being generated by GenAI, and also indirectly into the works that are derived from those content. So we use LLMs for writing papers, emails, advertisements, make LinkedIn posts and whatnot. So in that sense, by having the small system at the in prompting time, it is still very impactful through in the downstream tasks basically. And one more aspect uh, to consider of the system is that at the core of the system is a huge corpus of sentences from which the recommendations are selected. I'll talk about uh, how that exactly works, but I just want to point out that the system can be customized for any specific domain by just replacing or extending that corpus to include your domain specific language. Uh, I want to also talk about responsible prompting, the and how it is useful and who exactly it is useful for. If you're a prompt engineer, you already have the necessary prompting skills. You know exactly how to communicate with an LLM and get what you want out of it. But we see our project being the most useful to people with high domain knowledge. Here it's marked as SMEs, which is basically subject matter experts. They have very high domain knowledge, but they might not know how to prompt an LLM. They know exactly what they want to ask, but they don't know the intricacies of prompting and LLM. You can think about doctors, lawyers, and those kind of users. And generally, they'll exist in this green area where the domain knowledge outweighs their prompting skills. And by using this system, you can kind of educate them on how to prompt an LLM properly. And they also learn by using the system continuously. And the paradox is, as a user uses our system more and more, they'll start needing our system less and less, but it's still a win for the project. Now, I also want to define what responsible prompting means in this context, because there is a lot of definition for what responsible means in this tech domain. We define responsible prompting as effective communication with AI by adding responsible practices like inclusion, ethical behavior, among other many values, while also minimizing harms. And I also want to make this distinction that our system is aimed at improving the process of prompting rather than just improving the prompts themselves. This is how we differentiate this project from other optimizer type systems. Um, yeah, and this is like the general vision for how the system or this project can be used in your application. So down below is a visualization of how our prompting system guides the user into directions they want to go into. So this is basically a visualization of the embedding space. As you might all know, the LLMs convert natural language into a list of numbers, basically called embeddings, and they work on top of that. So within embedding space, with each sentence, your prompt is guided into different directions. And our system, the aim of our system is to guide it in a direction that is generally towards good values and generally away from harmful values. And one of the researchers at IBM kind of came up with this analogy that it is kind of like a GPS in embedding space. It takes the user to the destination, which is generally towards good values and a good, accurate prompt. So that is a very apt analogy for the for how the system works. And we also consider so when I say sentences, we also consider that each sentence represent one single value, which might not hold all the time, but it works. This assumption works pretty well. There might be a single sentence that represents multiple value, or like an entire paragraph of sentences that represents a single value. But for this use case, this assumption holds true, and it's a good balance between the two. And this works out pretty good. So I just want to show you this demo, which was presented at Think 2024, which is an event that IBM conducts every year to kind of showcase their projects for that year. And as you can see, there is a prompt and there are some recommendations that appear over there. So the green ones are additions. So these are values to be added to your prompt. And the red ones are possibly malicious sentences, harmful sentences that are recommended to be removed from the prompt. So I want you to observe this side-by-side comparison where without the recommendations, the model starts basically preaching about what ethics is and why this prompt is not ethically aligned, which is good, which is what we expect the model to do in that scenario. But when we are also wasting a lot of tokens on this, we are agitating it, we waste a lot of time, and it might get annoying when it's repetitive. So our system kind of prevents it by avoiding these kind of scenarios during prompting time. So at the end, you actually end up with a useful output instead of having to iterate over your prompt again and again to get what you want. And yeah, before I go to the approach, I would just like to see if there are any questions. If you want me to answer, I don't see any in the chat, so I think I'll
Yeah,
proceed for now.
I can ask a question if it's okay.
Oh yeah, of course. Yeah, go ahead.
Yeah, so like you mentioned that in the embedding space, one value represents an entire sentence, right?
Yes.
So let's say a doctor or a lawyer comes in and they give this entire prompt. Can you go back to the page you were showing where I think you crossed out some prompt and then added something? That
Is it?
ChatGPT interface. Yes, this one.
Mhm.
So, like, how does your application determine what part of the prompt should be removed? Because I believe that entire prompt is just represented by one embedding value, right?
So yeah, we do a few different things. That's why I talked about how we consider each sentence as independent values. So it basically splits your prompt into different sentences, and then it kind of flags one sentence as harmful if it's like too similar to a harmful sentence in the database. I'll actually talk more about it in the approach page. But yeah, that's basically it. Like it splits the prompt into its individual component sentences and then analyzes those sentences individually. Yeah.
Okay, so it breaks into sentence. I thought that the
Yep.
entire prompt is done by the embedding value. So okay, yeah,
Yeah.
okay, then that makes sense. Breaking into
Yeah.
sentences.
Yeah. So yeah, these are a few ambiguous decisions, but for example, you could say that by splitting it into sentences, we are losing some context around the prompt, around the sentence, and that's all true. But that's the kind of trade-off that we have to make, because we can't make like a perfect system that also works in real time and also provides this recommendation. It's like a lot of factors to consider, right? So this is the choice we made, but yeah, I'm sure we could improve it if you have any idea. Feel free to share. Um,
Yes, sure.
So yeah, I'll go into the actual approach and how it works. So like I mentioned, at the core of this whole system is this database of sentences that are split into generally good and bad sentences. So these also come with their associated social values. These were sourced from different data sets from different languages. We are trying to include new languages, but and also we included the harmful sentences from different adversarial uh, data sets, the ones like the prompt injection and stuff like that. And we also include the LLMs API embeddings in the corpus. And our recommendation API at the end is very simple. It's just a similarity search. When you give it a prompt, it splits it into different sentences, and each sentence is compared against a list of all the harmful values, harmful sentences, and if it's too similar to any of those, it flags it as a harmful one, and the user has the option to remove it if they want to. And for the addition, it also works very similarly. There are like different clusters of good values, and once the sentence is to very similar to a good value, it goes into that cluster and looks at all the sentences within and picks out the closest or the most similar one and recommends it to be added to the prompt. And those recommendations are passed on to the user. This is like the general schema of the API. And the API is very simple to use and it's very intentionally made that way. We hope in that way it's easy to just plug it in into your application and it's just ready to go. The first endpoint is, of course, the recommendation endpoint. You send a prompt to this route and it returns recommendations in a JSON format. The second endpoint is a little interesting. When I told you about using similarity search for recommendations, especially the addition recommendations, there is still a chance that a sentence that is exactly similar to your sentence in the prompt being recommended. But we don't want that, right? We don't want that repetition or redundancy. It will be annoying for the user. So we also set these kind of lower and upper thresholds for each addition. So any sentence that is added to your prompt or recommended to be added to your prompt should have a similarity that is more than the lower threshold, but also less than the upper threshold. So it actually adds that value to your prompt without being like a redundant recommendation. So that this endpoint specifically is there because this threshold is very specific to your choice of embedding model. So when uh, when you choose a different embedding model, you can just use this endpoint to identify the optimal threshold for your embedding models and maybe even your own sentence corpus. It just makes it easier to configure this kind of system. And yeah, here's a demo. We hosted it on Hugging Face. Let me just actually show you a few things there and how it works. Yep. So I hope the Hugging Face space is visible to you. So this demo is just modeled as a simple chat application like ChatGPT, for example, but it could also be incorporated into any kind of Gen AI related system. For example, in image generation models or whatever, anywhere you have this kind of language input, you can plug in our system. So let me just reload to show you how the recommendations are generated. Here you have a sample prompt, and the recommendations are generated for that prompt. And here are a few, one sentence that is flagged as possibly a deceptive sentence, and it recommends removing it, and a few values that can be added to this uh, prompt, basically. And you can click on that value to add it, and you can also click on the removal to remove it. And let me also show you this graph, which is basically what I told you about earlier, the kind of visualization in the embedding space and how these recommendations take you away from the harmful ones and towards the more good values. And yeah, you can chat with it. And uh, I'll also show you a couple more prompts to kind of show you how the recommendations work. Let's see. So here it's about a project manager trying to monitor someone's private messages, which is not good. And it recommends removing the sentence. It also recommends it to add uh, things about privacy, security, and safety. Uh, and then here's one more prompt. Here again, someone wants to get a pirated copy of a software, and here it rightly recommends you to check for any copyright issues and use possibly open source software rather than using these kind of pirated versions. And this is how we see it being helpful for users that especially are not aware of how to prompt LLMs specifically. They are not very what do you say uh, skillful in using these kind of applications. Let me reshare the presentation. And yep. So here's a link, and the QR code also takes you to the same link of the demo. Feel free to try it out and let us know what you find. Uh, Especially try out prompts that you would use in your daily life, like for coding or whatever, and see if the recommendations are helpful, or if you if it is helpful, let us know. We'll try to improve it. Even if it's not, let us know what you would like to see there. And here are a few research papers that kind of describes the journey of this project. The first paper is actually the approach exploration. Initially, before deciding on this sentence similarity approach, the team actually tried out using LLMs to provide recommendations. They also fine-tuned a particular LLM to provide this kind of recommendation. And at the end, we they settled on sentence similarity because it is a good balance between the accuracy of recommendation and also the speed. The speed is an important factor because we want everything to be done pre-inference, like during prompting time. So as the user types in the prompt, you want to recommend suggestions, and you don't want it to be too slow or intensive. And the second one is a user study, and it's a very good paper. Um, with an earlier version of this prompting system, they did a wide user study, and it really gave them a lot of good insights into how users actually perceive the system, how they use it. And we are actually right now working on some features that solve problems that were pointed out by this user study. And the third one is a technical report. It talks about the details of the system and a few different embedding models that were compared, and how the uh, optimal thresholds were determined and stuff like that, if you're interested in those kind of things. And yeah, if you don't have time, I would really suggest just going through the user study at least. It's a very good paper, I would suggest. It looks at it from a different side of things. I think we are all used to reading very technical papers, and I think this might be a good new perspective for you all. Um, so yeah, what's next for this project? We right now are focused on improving adoption of this system into anyone's application inside their project. Uh, we want to bring as much visibility to this project as possible. And right now, we are also working on two things technically. One is to expand this data set, this sentence corpus. using synthetic data generation. We want to pick new values and also expand the earlier existing clusters so that the recommendations are more aligned with what you want. And also, we are working on prompt modifications or rephrasal, for example. So, currently, when you find a harmful sentence, it is removed entirely, which means you are also losing some sort of meaning with it. So, one person is working on trying to rephrase the sentence without the value, the harmful value, so that you're still able to retain the general meaning of the prompt. And the last thing, and probably the most important thing, and where we want your help, is to build this open source community around it. So the main reason and why it is especially important is that at the core is a sentence database with certain values that are considered good and bad. That is not something one person or one team can decide for everyone. So we want people from all over the world to share their perspective, add recommendations to the uh, JSON or the database, and in that way, as more people add to the database of shared social values, the more robust our system becomes. And finally, a few key takeaways. Our system at the very basic level is to improve the quality of prompting, and it also focuses on making the process of prompting quicker. What we mean by that is we all have faced the scenario, right? We start with a prompt, we get an output, it's not to our liking. We go back to the prompt, we modify it again, and we do this again and again, iteratively until we reach the output that we desire. But with this kind of recommendation system, it guides you to a proper prompt, an accurate prompt, without having to do that many iterations or that many modifications by the user. So I think it might save a lot of time and effort from the user's side. We also see this project as an educational tool. So anyone that's new to this field, or even for prompt engineers, I think this kind of system will uh, has some educational value to it. And at the end, we also want to focus on avoiding harms when using these models. Uh, like I said, most users are not necessarily doing that intentionally. So we want to try and avoid these kind of prompts that are not very visibly harmful to the user, but still are harmful, right? So we want to flag those sentences, point it out to the user, and say what they can add or remove from it to make it better. And on the left is actually a link to the AI Alliance page. So the AI Alliance is a consortium of different companies that come together, and they are trying to build this open AI ecosystem. And IBM is a part of it. And this project specifically is affiliated with the project. You will be able to find a lot of different projects under AI Alliance. Please take a look, and I think you'll find it interesting. And at the end, yeah, please do star the repository and also like our demo. We want to bring this project out to as many people as possible. So do share this with your friends, and also please engage in the discussions and on GitHub and share any ideas you might have. If you find any flaws, and please open issues. And if you want to contribute, get in contact with us. We are happy to take in new contributors. If you need any help in understanding how this system works or how to contribute, don't hesitate to reach out to us. This project really relies on the community to succeed. And yeah, that's all I have for today. And I'll first take some questions. And if there is still time left, I'll probably walk you all through our GitHub repository. We also have some cookbooks there to kind of introduce you to the different technical components in our system. I'll just show it briefly. I think we'll probably end with that. So if you have any questions, I can take it right now. Let me see. Yeah, Salim. Yeah, Taha, Salim, please.
Hello. Hello, Ashwath. So yeah, the great presentation. I just had a question regarding these pre-sourced embeddings that you have, with which you do sentence similarity.
Mhm.
How much, I would say, technical jargon do they contain of special domains? For example, in a medical field, if a doctor writes that this is a patient's report and
Mhm.
assume a high probability of carcinoma despite benign tumors, something like that. That is so. Do you guys, for specific domains, have these kinds of embeddings to do sentence similarity with?
Yeah, so the thing is, you pointed out like one main thing, that is when you apply it to a specific domain, the system might not work as expected. Like you said, specific terms might not be understood by the embedding model or even the LLM for that matter. So in that sense, I think uh, first of all, the corpus could be enriched or extended using to add sentences with the domain specific language. For example, if you are applying it into a medical related chat application, you should probably add some sentences that are related to that into the sentence corpus. And there are also, I think, embedding models that are fine-tuned towards certain domains. So that might also something we could take a look at. But yeah, in general, like you say, that is a concern. Like it might not be directly applicable. You should make some sort of like uh, you should switch out like embedding models or add these sentences to the corpus, and in that way you can still use our system in that context. Yeah.
Yeah, adding sentences would be easy for
Yeah.
non-technical users also. Yeah,
That is very,
thanks, Ashwath.
yeah.
Thanks.
Mhm. Thanks for the question. Yeah. And Arion thus, yeah.
Yeah, I had another question. So yeah, first of all, great presentation. Thank you. So let's say we have a sentence, and in that sentence we have some positive sentiment context and some negative sentiment as well. So will that
Mhm.
sentence get flagged then by your application?
Probably, yeah. It will get flagged. So if it has any explicitly harmful word in it, it will be too similar to a harmful sentence in the database. Again, at the end, it's all a similarity search, right? So the strength of the system, it's basically dependent on how comprehensive this sentence corpus is. And yeah, if it contains both values, it will probably be flagged. Yeah.
Okay. So then I think a better workaround will be using word level embeddings instead of sentence level, right?
Yeah, maybe. Yeah. Yeah, that might
But
actually be a
yeah,
good thing.
but
Mm.
that makes it more complex, right? The latency
Yeah.
increases.
Yeah. Yeah. And yeah,
All
one
right.
more point I want to yeah, tell you all about is that this is one of the main reasons that the system is modeled as a recommender system rather than just something that goes in and modifies the prompt for you, right? You can see a lot of these prompt optimizers. You give it a prompt, it returns like a optimal prompt, which might change the entire meaning of it. So the team made it an intentional choice that it has to be a recommendation and just a recommendation. So the user has the entire like the freedom to choose to use it or not. So that is one aspect that the team considers uh, to be needed in all these kind of systems. And yeah, so in that sense, like when it flags, right, like one the example that you brought up, if it flags it as a harmful sentence, the user still has the choice to see that, it flagged because it's representing this value. Maybe I'll just remove this value from the prompt. Maybe they don't have to accept the recommendation, they just have to modify it. So in that way it's still, yeah, useful, I believe. But yeah, what you say is still holds. Yeah.
Yeah. No, what you said, that also is true. That can also be done. Yes.
Mhm.
Thank you.
Yep. Yep. Thanks for the question. And yeah, I think we still have more time. So let me just, oh, I don't,
Hi. So I did have a question, but it sort of got answered along the way because it was about if there was a plan to have a repository of, for example, updated maybe words that we find as a community to be harmful and maybe those could be pulled in by other people. But it seems like maybe that could be taken on as on an individual basis, and that's sort of like the way the program is going. Yeah, so I guess that's fine.
Yep. So yeah. Yeah, I think I don't see any more raised hands, so I'll probably switch over to the GitHub repository. I'll just show you around the repository to find certain things. Let me stop sharing. Okay, so yeah, this is the main repository. Please do go and start it. Uh, Here we have a lot of different things, but one main thing I want to focus on is this prompt sentences. This is basically the dataset that I was talking about. And one disclaimer before I go into this, it has both positive and negative values. So the negative values by nature are offensive. So if you are not comfortable with it, just a heads up before we go in. So here are the entire JSON is split into two major chunks. One is positive values, and the other bottom is contains negative values. And within each positive, within the positive value section, you have like clusters for each value containing different recommendations. And these are by no means comprehensive. And that's why we need the community to come in and add more values and more different perspectives or even complete values if they want to suggest. And here you will find certain negative values. And at the end, we also try to give credit to the sources that we take these recommendations from. So we will also make sure to give the correct attribution to where the data is sourced from. And these are, so here you see that the embedding column is left empty. So this is kind of the template document. Now, if you also add in specific embeddings from, for example, all mini LM model, it's too big, but let's see if it opens up. So yeah, here it's also populated with all the embeddings. And that's the only difference. So these are all basically the same file, but this is probably the main one, I would say. And going into this part, this is a cookbook which takes you through like different components in our system and helps you understand the code. So if anyone's especially interested in contributing technically, this would be a good place to start. I'll just maybe go through one of these. This is like a general API level overview. And yeah, to run this, you need to have this secret setup. It's basically a Hugging Face token. You can get it easily. You just Google about it, and it's very easy to get. Here we have some imports, and this query function is basically given a prompt. It returns embedding. So when I say prompt, I mean sentence, sorry. So when you give it a sentence, it returns the embedding for that sentence. And we have this default model setup, which runs locally. Otherwise, for all other models, it runs on an API. Like it requests the Hugging Face API for that model and returns gets the embeddings and returns it. And you also have this function. This is the main one. So you see these thresholds, right? These are like very configurable parameters, and it depends on what kind of embedding models you use. And here it basically goes through every single positive values and sees if it's close enough. Like I talked about the lower threshold and upper threshold. So if the centroid of that value is greater than a lower threshold, it goes into that cluster and looks for the closest sentence. And those sentences should also be not too similar to the sentence in the prompt. So you also use this upper threshold to kind of prune down the search. And here it goes through each input sentence, goes through the list of negative values, and again picks out what might be harmful. So here are some sample recommendations for this prompt that was given. It suggests adding trust and whatnot. Uh, uh-huh. Okay, okay. Yeah, I think it's switched to a new tab. Let me maybe share the window. Thanks for letting me know. Where is it? Hmm. I think now maybe I should be able to see everything. Yeah, sorry about that. So, okay, should I just, yeah, I'll just go through it quickly again. So this query function is to get embeddings for a given sentence. We default to a local running model, which is still pretty good. Otherwise, we request the Hugging Face API, and you can use whichever service you prefer. And this is the main recommendation function. Here you see the thresholds. And this is where the similarity search basically happens. Uh, for each sentence, it goes through the list of positive values, all the clusters. And if a cluster is centroid, we do that clustering to make it a little more efficient, right? We don't want to go through the thousands of sentences in the database each time. So we look for clusters similarity. And if it's greater than this lower threshold, we go into the cluster and look for the most, or what do you say, similar, most similar sentence. And that also obeys this upper threshold. And similarly for negative values, you go through the database and see if it's too similar to a particular harmful sentence. Here, the upper threshold, of course, is used differently. We use the upper threshold as a limit for the, what do you say, for an individual sentence to be as similar to the input prompt sentence. And here you recommend return the recommendation as a JSON. And here are some examples. So for this prompt, these are some of the values that were recommended to be added, like safety and trust. And along with it, you also see similarity scores and X and Y coordinates being returned. So these X and Y coordinates are actually for the visualization. They are not actually a part of the recommendation. These are generated using UMAP. So you know that the embeddings usually are in a very high dimensional space. Usually it's like 768 or 1024 or whatnot, depends on the embedding model. We use UMAP to kind of compress it down to or project it down to a two-dimensional space for better visualization. So you can also find the remove, what sentences has to be removed from the prompt. And we also have a few different, so for example, this is a situation where the coding it's it is what we recognize, right? Here it recommends adding this sentence, which something goes along the lines of generalization and also making the models more robust. So it also can be useful in all domains. So this is just a example for that. And yeah, please go through all these notebooks. They are very helpful in understanding how we wrote these systems. And yeah, I think that's all I had to share for today. If you have any more questions from that, I'm happy to answer. I'm also available on Discord. So if you want to just message me regarding anything, yeah, I'm happy to guide you in these things. Yeah. Thanks for attending the session. Yep.